So this chapter deals with solutions. Let's first start off with a few definitions that you need to know. Number one, what is a solution? It's basically a homogeneous mixture of two or more substances, and each one of those substances retains its identity. This is very important because you can separate out the components of a solution by physical means. So this is a mixture, remember, it's not a pure substance. You haven't created a new molecule or anything. They're just two or three things all attracted to each other to create a nice homogeneous mixture, okay? So each one of the components of the solution retains its own identity. But since it's homogeneous, it's uniform throughout. So you can't like visually see the difference between the components of the solution. Now, the two main components are called solute and solvent. So when you have a solution, the solute is the thing that you have in a solution that's in lesser amount. The solvent is the thing that is in greater amount. So for example, if you have a solution of alcohol and water, and it's all uniform, and I tell you that 80% of it is water and 20% of it is alcohol, that means the alcohol is the solute and the water is the solvent. If I tell you I've got some sugar dissolved in water, the terminology dissolved in immediately tells you that the water is the solvent and the sugar is the solute. Let's say I have a gas solution where I've got carbon dioxide and oxygen and nitrogen, sort of the air that you breathe. Do you guys know what gas is the one that's in the largest amount? It's the nitrogen. So the nitrogen would be considered the solvent, and the oxygen and the carbon dioxide and any other gases would be considered the solutes. All right? So solutions can be gas solutions. They can be solid solutions, like the gold jewelry. It's not pure gold. It's gold with other metals dissolved in it. So it could be a solid solution, a gas solution, or a liquid solution. Most of what we deal with in chemistry are liquid solutions. And most of the solutions we deal with are aqueous solution. The term aqueous just means that the solvent is water. So if the solvent is water, it's called aqueous solution. And you've seen that terminology before where I told you guys AQ. If you see an AQ right here to the bottom right, it means that this sodium chloride is dissolved in water. It's an aqueous solution. All right. The term solubility, another term you guys need to know. It is the maximum amount of solute in a given amount of solvent under specific conditions. And it's important to say under specific conditions because solubility will change if the conditions change. For example, if you put sugar in water and it's ice cold water versus sugar in boiling hot water, think about this. You could probably dissolve more sugar in the boiling hot water than you can in the ice cold water, right? So the solubility is affected by temperature, and if we're talking about gases, it's also affected by pressure. Now, solubility is usually measured in grams of solute per 100 grams of solvent. And you have a table in your book that talks about different solubilities of different components at different temperatures. So the two main things that affect solubility are temperature and pressure. What do we need to know about that? Well, as the temperature increases, the solubility increases for some things, not for everything, not for everything. So usually a solid in a liquid tends to increase with temperature. That was the example I gave you guys with the sugar, same thing with salt. So if you increase the temperature, the solubility of a solid in a liquid tends to increase. However, If you increase the temperature, the solubility of a gas in a liquid actually goes down. So as the temperature increases, gas solubility actually goes down. Okay, as temperature goes up, gas solubility goes down. So it depends on what you're talking about, and usually there are tables there that will tell you what will happen to that substance. All right, what about pressure? Well, the only thing that's affected by pressure is a gas. So let's think about this. Will a gas be more soluble in a liquid at a high temperature or at a low temperature? Think about a pop sitting in your garage on a super, super, super hot day versus a pop sitting in your refrigerator. You take both bottles out and you open them both up. You taste them both. Which one's going to feel more fizzy, more carbonated? Usually the one that was in the cold, because you have better gas solubility in colder temperatures. As the temperature goes up, oh, I already mentioned that. Solubility goes down. Solubility goes down. So I already mentioned that. But what about the pressure? Okay, has nothing to do with temperature. Sorry about that, guys. All right, as you increase the pressure, I mean, how do they make carbonated beverages anyway? They apply pressure and force the gas into the liquid, okay? So forget the whole thing about temperature. Now let's focus on pressure. Pressure affects gas solubility. As you increase the pressure, you increase gas solubility, okay? So what you know when you open up a pop bottle and it goes, psh, what's happening? You're releasing the pressure and the gas starts to go out. So whatever it's, and if you're one of those people that opens up a pop or any carbonated beverage and you leave it out, after a while and you start to drink it, it has no fizz to it. So you've released the pressure, the gas has escaped. Bottom line, what do you guys need to know? No, as you increase the pressure, you increase the gas solubility. And this ties into a law that's called Henry's law, which basically says as you increase the pressure, the solubility increases. That's basically it. Okay, so now let's talk specifically about solutions. And the main solution that we're going to be focusing mainly on are an unsaturated solution. But there are three types of solution. There's a saturated solution, saturated. So we'll write three types of solutions. Saturated solution, unsaturated solution, and supersaturated solution. Okay, so let's first talk about the saturated solution. A saturated solution, it has the maximum amount of solute in a given amount of solvent. So maximum. So if you add any more solute, you know what's going to happen? It's going to fall down to the bottom, or in more technical terms, we say it precipitates out. So in a saturated solution, it's got the maximum amount of maximum amount of solute in the solvent. Any extra solute would precipitate out, okay? An unsaturated solution does not have the maximum. So it's less than the maximum amount of solute. Okay, so what happens if you add more solute? You can dissolve some more in. So unsaturated solutions are the ones we're going to be focusing on. Those unsaturated solutions can be dilute or concentrated. Okay, a dilute solution doesn't have a lot of solute. A concentrated solution has a lot of solute. So concentrated, unsaturated solutions have lots of solute. Dilute, unsaturated solutions have less solute. Okay, and we're going to be talking about measuring concentration and concentration units in a few more videos. We'll get into that. All right. The last type of solution is a supersaturated solution. This is unstable. This has more than the maximum amount of solute. Okay, so how did they do that? We just said that if you add more solute, it's going to go down to the bottom. So how do you get a supersaturated solution? It's a pretty cool trick. What you do is you put the solute in the solvent, and you mix it all up, and you make it saturated. And then you increase the temperature. And then you add more solute in. So it's all going to dissolve. And then what you do is you cool it down. Okay, slowly cool it down. It's like you're tricking it to hold more solute than it should. So then when you cool it down, this solution is just carrying way more solute than it's supposed to. And one small irritation, agitation, makes all the solute crystallize out. So it crystallizes out. That's how they make rock candy. And in lab, hopefully you'll get to see one of those types of scenarios where you have a solution at the right temperature, saturated, increase the temperature, allow more solute to go in, and now it's saturated at a higher temperature. But then you're tricking it and you're bringing down the temperature. It's carrying more than it should. Very unstable. One agitation, they start to come out not as a precipitate, but as really interesting looking crystals. It's pretty cool to see. So if you've ever eaten rock candy, that's from a supersaturated solution. Okay, so I think we got all the terminology down. We'll do some other things in the next video. Okay.